So we are writing practically that one as very easy. That is D Moivre's theorem. And why that is called De Moivre's theorem? Practically the ABRA, the Abraham Day or D Moivre from 1667 to 1754 was one of the mathematician, you can also say as economist him, uh, to use the complex numbers in trigonometry or trigonometry. And according to his name, that theorem has been defined as De Moivre's theorem. So what he says, practically that is given, suppose let the complex number given according to trigonometrical form is, suppose in place of x we are writing it check cos theta, and in place of y we are writing it as sin theta, and we have any integer that is small n. Okay, then cos theta plus I sin theta whole to the power n can be written as very important cos n theta plus I sin n theta. Just look at the n. N is nothing, just multiplied with the angle, which is as an power. So that is our De Moivre's theorem according to for the complex number. Now from that particular De Moivre's theorem, we can also derive some other type of formulas. Like first one, we can say if that one is plus, we are writing here that is cos theta minus I sin theta whole to the power n. So that is the same way, cos of n theta minus I of sin n theta. Okay. Second one, cos theta plus I sin theta whole to the power, suppose, minus n. Okay. Then what we can write? Let's check whatever be the power is here. We are multiplying it with the angle. So here we are also writing cos of minus n theta minus of minus sine minus n theta. Now look, cos of minus n theta, that is also same as cos of n theta. Cos of minus theta is equal to cos of theta, but sine of minus theta is always equal to minus sine theta. So that is also the same here. So minus of minus is now becoming I of sine n theta. Same as number 3, if we have cos theta minus I sine theta whole to the power minus n, that is cos of minus n theta, which can be written as cos of n theta, and minus of minus n theta, that means which is becoming plus of, sorry, the first one was wrong because that one was plus. So when we are writing it here minus, so that one is becoming minus. It has to be notified. That one was plus, so here that one is also plus. So when we are writing it, that is plus into minus, that means minus. In that case, that one minus. So minus of minus is now plus. Okay. And the fourth one, the derivation from here, that means if we have sine theta plus I cos theta, that means nothing to the power simply 1. We are taking common as I. So if we take the I as a multiplier, that one is becoming cos theta minus I sin theta. Very important, that one is also. Sin theta plus I cos theta is equal to I of cos theta minus I sin theta. Let's check the de Moivre theorem. It's a problem. Suppose the first problem, if Z is equal to cos theta plus I sin theta, show that z to the power n plus 1 by z to the power n is equal to 2 of cos n theta, and z to the power n minus 1 by z to the power n is equal to 2i sin n theta. Okay, let's check with the same thing. That means we have z to the power n at first. Okay, so z is equal to cos theta plus I sin theta whole to the power n, which can be written as cos n theta plus I sin n theta. Very good. Then 1 by z to the power n, that means which can be written as z to the power minus n. That means cos theta plus I sin theta whole to the power minus n. Now check cos theta plus I sin theta whole to the power minus n. That means cos n theta minus I sin n theta. So we are writing it as cos n theta minus sin I sin n theta. Okay. Now find out z to the power n plus 1 by z to the power n. Just add those. Cos of n theta plus I of sin n theta plus cos of n theta minus I of sin n theta, which is becoming, you can subtract those. So the result is here 2 of cos n theta. And when we have z to the power n minus 1 by z to the power n, that is cos of n theta plus I of sin n theta minus cos of n theta minus I of sin n theta. Here we can subtract cos of n theta, but that minus and minus becoming plus, so that is 2i sin n theta. That is the same thing whatever we have to prove. Okay, let's check another problem for the de Moivre. Here we have to simplify that sine of pi by 6 plus I of cos pi by 6 whole to the power, suppose 18. Okay, let's check what is happening. If we have sine pi by 6 plus I cos pi by 6, look at the formula here. When we have that is sine theta, suppose I am writing here sine theta plus I cos theta can be written as I into cos theta minus I sin theta. So here is also we can write it as I cos of pi by 6 minus I of sine pi by 6. Okay, so we are taking the power 18 on both sides. You can say that taking as also raising. Okay, so that one sine of pi by 6 plus I of cos pi by 6 whole to the power 18 is I to the power 18, that one is here, and cos of pi by 6 minus I of sine pi by 6 whole to the power 18. Okay, let's check. That one is equal to I to the power even, that is always minus 1. I to the power square, that means minus 1. I to the power 3, that means I, but minus I. But I to the power 18, that is minus 1. Not even, that is 16 plus 2. That's why. Now, n is 18, so we can write it as cos of 18 pi by 6 minus I into sine 18 pi by 6. Okay, let's check. Minus 1 into cos of that is 3 pi minus I of sine 3 pi. Now, which one? The first one, minus 1 into cos 3 pi, that gives us minus 1. That gives us minus 1. Minus of that 3 pi means 0. So that gives us 1 plus 0I, or the value is 1. So simply when we have to simplify, look at the value. Sine pi by 6 plus I cos to the power pi by 6 whole to the power 18. That has been simplified as 1. That is the answer, and that already we have used the de Moivre's theorem.